Yeah, okay.
Okay. Hello, everybody. I'm Sonia. Is my voice loud and clear? Yeah? Or should I use a mic?
Yes.
For the audience in the
Zoom call.
because it will take a bit.
Okay.
So that she doesn't have to go to loud.
Again, good morning, everyone. Thank you for joining with us. So today, the agenda of this meetup is we'll have two technical sessions. So the first session is by deploying of ML models with web services. So we will be having a few different types of deployment, especially with Docker, SQLite, all those things. So our second session will be on AWS SageMaker. That's again related to ML deployment. So I think we can start with the session. So first speaker is Sonia Mehta. She's working as an ML engineer. So she has been delivering a lot of sessions to so many communities in Chennai and Bangalore. So I attended a couple of her talks. I had talks, so I was much interested to have her as a community speaker also. So I asked her, she agreed to that. So then second session will be by Isa Rain. So I'll give a quick introduction at that time. Then we'll have it. We are planning to close it by 12 o'clock, around 12 o'clock. For that, we'll have some small lunch and we'll close by 12:30. That is the plan for the day. I think Sonia can start.
Sure. Also going live.
Yeah,
in
so
YouTube.
for mathematics also people are joining and online, and it will be available in YouTube also. Later we can just see for our reference. I'll share the links later to me.
Okay, let me take over. Hi everyone. So today's session, we're going to cover, it's all going to be beginner level. We will start from saying what machine learning is and what machine learning deployment is, what are the different stages in it, and how do we deploy machine learning models as web services. So we're going to figure out what web services are, what are some of the Python frameworks that we can use to get started with the deployment. And yeah, we're going to look at some of the tools like Flask and Streamlit and some best practices around machine learning operations. So before I dive into the session, just a little bit about me. I'm a machine learning engineer at EXL Health. So my day-to-day job involves talking to the data science team, getting all their requirements up and analyzing their code, reviewing their code, making sure it's all optimized and production grade. And I also work in the data pipeline side. So I look after the end-to-end pipeline of getting the data and the infrastructure ready for the machine learning team, helping them analyze and experiment with a lot of algorithms and getting that infrastructure up. And also, when it comes to deployment, I help them with their deployment tasks, monitoring of the models, etc. So I'm skilled in Python, PySpark, Docker, Airflow, and of course, machine learning. And so fun fact about me, I graduated in Bachelor's of Business Administration, and then I paved my path into data science. So yeah, it's been a very fruitful journey so far. And I've been a speaker at a couple of tech conferences now. My journey of talking and speaking community started a few months back. So, and I'm a cloud and open source enthusiast and also a mentor to a lot of budding data science aspirants across. So if you're on LinkedIn, please follow me. And yeah, let's start. So what is machine learning, right? So in the most simple terms, it's looking for patterns in data. And once we figure out what those patterns are, we kind of write a framework around it. So we generate a code to capture those patterns. And then we recognize those patterns in new data. So once we have generated a code to figure those patterns, all we have to do is apply that code on new and predict if predict if that particular pattern is found or not. So today's session, we're going to choose a problem statement, and I think it's a pretty common, familiar one across any industry, and it's called churn prediction. So churn means when your customer shifts from company to a competitor, right? And let's say if there's a telecom company which provides internet and other kind of networking services. So let's say a couple of customers. Now they need to understand if their customers are about to churn to a new telecom company, right? Now they're particularly interested in this problem because they understand, given the information about their customers, what is the likelihood that they might churn? Likelihood as in the probability that they might churn. So let's say about this customer, they have all their demographic information, their gender, how many months they've been in the been with the company, how many, what's the tenure, what's the monthly charges they're paying, and we know a couple of things about a customer. Now, how using the historical data, how do we come up with a score? Let's say we assign a score to you, saying that, okay, what is the likelihood that you might churn and move to the new telecom company, right? So let's say there are a couple of them, and you see the scores, and the last one has a very high score of churn. So let's say we create a model, okay, which is able to do that, right? So now what the company can do is they can identify this high risk candidates, the high-risk customers, and send them promotional emails and send them, and then use their marketing service to maybe like send a a promotional mail that you might be getting a 25% off next month if you stay with us, right? So that's so that's the way companies might entice their customers to stay with them. So we're going to look into this, and obviously we'll cover the ML ops part of it. But just to set the pace of the session, I wanted to share what a typical machine learning pipeline looks like. In most of our organizations, we start off with a couple of business heads coming and talking about the use case and what they really expect the model to do. And after that, we brainstorm about the different data sources and how we're going to collect all of the data and assemble it as a feature store, right? And once we get all those features and the data ready, what the data science team now does is they perform exploratory data analysis. Now that means they find out some meaningful insights from the data. What are some of the most meaningful features that probably from our use case, it defines churn, right? How does the gender of a customer affect churn? So we look at a lot of correlations. So correlation, again, is a statistical word saying how one feature affects the other, right? So they do a lot of data analysis, and after that, after processing all the outliers, the missing values, then they look at the features. And they select the best features out of all of the features they have. So let's say the model has, the data set has 1,000 features, but your machine learning model doesn't require all the features, right? So feature engineering is the part of the pipeline where they choose the topmost features, and then they start off with model training. So model training involves experimenting with a lot of algorithms. So they keep going over different algorithms, checking the precision scores, the accuracy. And then once they figured out the best algorithm to go for their use case, they start off with evaluation. So evaluation is when you test your model on new data, right? So you check if the model performs well and generalizes well on the new customers that are coming in. And once the evaluation is all set up and you have a machine learning model ready with you, right? Now, so far, whatever I've spoken about happens mostly on Jupyter notebooks, right? So we use that development environment and we code, we do a lot of experiments. It's all in a Jupyter notebook or maybe PyCharm, whatever editor you're using, right? Now, the model is ready. What happens next? these business leaders would be like, okay, what about the customers? How is our other services in our department, in our company, like the marketing department, how is it going to use our model? How are we going to make our model available to them? Obviously, we cannot give our Jupyter notebooks and ask them to run the notebook, right? We have to figure out a way in which we can expose some kind of a URL, some kind of a some technique to help them make predictions using our model, and that is when deployment comes in, right? So the deployment team, the DevOps team, MLOps team, actually, they jump in, and so there are certain steps we follow. So I've given a very high level view, and this is to kind of set the pace of what we're going to do next, right? So first is we package the model. So once we have the machine learning model ready, what I mean by packaging is, how do we convert the model into a binary file, right? So we have the model in our Jupyter notebook. How do we convert it into like a binary file, which can be again loaded on to any kind of environment, and it could be used again and again repetitively. So that's what we call as saving and packaging the model. So once that is done, we brainstorm about the application skeleton. How is our machine learning service going to look like? What are the components that we I think the screen lost. Just a second. I'll share the screen again. Visible now? Okay. Okay, I'm unable to play it. Okay, no issues. Okay, so I was here at the steps to deploy the machine learning model, right? So we were talking about the application skeleton. So what I was saying is, once the model has been packaged, now you want the end consumers of the model to use it. Now we would kind of give them expose an endpoint or a URL of some sort and allow them to access our machine learning service through that endpoint, right? So we're not going to give them the script, but we are allowing them to access the model through a URL. So that's what I mean by application skeleton. So we design that, we test the application, of course, and then we package the application. So when I say packaging the application, it means that there are a lot of version dependencies. When you're running a machine learning model, you have certain packages, and they're all, you need to ensure that your model can be run on any environment, on my computer, your computer, on the cloud. So you need to package your model, and that's when services like Docker come into picture. And at the end of it, we design a user interface. So let's say there's a requirement that your marketing service, the user of your machine learning model, they don't want to run some kind of a script, right, to get or make an API call. So they just want to use some kind of interface. They just want to click a button, and then they want to get the predictions out, right? So how do we create such a application? So we talk about, so these are all the steps I'll be taking you through in the next few slides. And once all of these 5 steps are done, then the final production stage, right? We need to think about fault tolerance, scalability, reliability. So these are big terms, and the entire DevOps team, they work on ensuring that the infrastructure is the right one for our model. It can handle a lot of requests, and it is able to scale up, scale down, and that's when cloud services come into picture, right? And because it's practically very difficult for us to have clusters and servers running within our company. So we rent them out and we borrow their facilities of load balancing, caching, and all these things from the cloud services. So I'm not going to cover this part. So this is a whole new area and it requires a lot of sessions to explain, but I'm going to take you to the first 5 points. And by the end of it, you will know how to package your machine learning model and create a Docker container. And once that Docker container is ready, you're good. You can now deploy it anywhere, on the cloud, on your physical server, on a virtual machine. So the main point is, how do you get your machine learning model into a container, right? So once you package it, you're good to go. You can deploy it anywhere. So that's the aim of the session. And I've put all my code on GitHub, so you can find it and play around with it as I'm going through the slides. So, yep. Okay. Yeah, thank God. So, so I have a nice picture here. So it will just summarize whatever I've spoken about, right? From your Jupyter notebook, how do you take your model and save it as a binary file? And now we want this model to be inside our churn service. And let's say we have some kind of a department, like a marketing service department, who wants to use this churn service, right? So they can make a request to this churn service by giving some information about a customer. And in return, the churn service can return the churn value, right? Is the customer going to churn or not? Some kind of a prediction in return. So machine learning in general is about that, right? It's about making predictions. So once the churn service is able to give a score for your customer, the marketing service can then decide, oh, should we give them a push notification saying that you might get a 25% off next month, right? So this is what we're going to design now. And not just about designing it, I also wanted to show you some of the best practices and frameworks that in my experience have been super useful. So once we have the model ready and we wrap it as a web service using Flask, we would then package the entire Python environment so that it doesn't mess with other projects that we have, right? So for that, we're going to use Pipen. So there are a lot of frameworks, but I've selected Pipen because it's quite popular in the community. And then we will package one more layer on top of our model using Docker. So that will ensure that our model can be run on any environment, whether it's your Windows computer, Mac, Ubuntu, any kind of OS. We would be able to push any OS which has Docker installed in it. It will be able to run our model, our churn service model. And once we have the Docker setup ready, obviously we can deploy it anywhere, as I told you, right? You can take it to the cloud, any physical server, VM, anywhere, right?
Are we talking about the Docker container or the image? So you're shipping it.
Yes.
So we'll be using a Docker container or an image.
So yes, you can take the image. Of course, image is the definition of the container, right? So once you run the image, you get a container. Yeah, so that's what I meant. It's taking an image. So yeah, let me introduce Flask to you. Now, any one of you who knows what a web service is? What is a definition of the web service?
A simple set of API endpoints which a user can access, running through HTTP.
So it's a way of communication between two services, right? So if someone sends a request to an endpoint, as he said, how do you get a response back from it? So that entire communication layer. That's called that is called as a web service, and there are obviously a lot of frameworks around it, but I wanted to introduce Flask to you today because it's a very Python based framework. You don't need any kind of experience with front end coding, or you don't. It does everything under the hood for you. So it does the HTTP, the protocolling, the network setup, everything happens under the hood. And all you have to do, I'll show you the code in some time. is define the root, define put your model inside a function, and allow your user to make a request, and you would be able to get a response back, right? So let's take a simple example of this. Let's try to write a simple ping pong app, right? So let's say the user sends a ping request. The Flask should be able to send pong in return. Okay, now let's see how to do that. Okay, so okay. Can you see my screen? Yeah. Okay. So, I've defined a very simple setup, right? So all you have to do is import Flask. Now, how do you install Flask? It's just pip install Flask, right? And because I've already installed it, so it will say requirement satisfied. So, but in your setup, it would look a bit different. So once you've installed Flask, all you have to do is create the application. So you just call the Flask object and you write. So this minus name is actually a global variable that is defined by Python itself. So when you're running any application, underscore name is actually the main string. So if you're running this Python file, your name variable is automatically assigned to the main string, right? So once you've created the application, we are going to write a function, right? So this is a function. It's called define ping. Okay. So if it returns pong, so it just returns a simple string. Now on top of that, I've added a decorator. So this app.root is basically an additional functionality. Zoom in a bit. Yeah. Command plus. Yeah, I tried that. It's not working. Okay. So, right, so we're just defining the function, it returns pong. And when you do app.root, it's basically a decorator of Flask. It handles, so it handles a root, right? So you define at this particular, so if my user has, it goes to the root /ping, okay, it should return pong, right? So we are kind of defining the URL endpoint saying that if it ends with ping, the user should see pong, right? And you can see something called methods here. So, so Flask has multiple methods. So methods make it easier for the communication to happen. So when you type, when you say the method get, so that means the user is requesting data from the server, right? And the user is not sending anything. So that is the get method. And if the user wants to send something to the application, they would use the method post. And in return, the server would reply with something. So this is basic protocols of an API that you can find, like you can just Google and see what are the different ways you can communicate, right? And so we're using the method get. And so now we are trying to run the app, right? So if name is equal to main, let's run the app on our local host. So 0.0.0.0 means my local computer and port is 5000. Now these two are actually the default, like Flask uses these two parameters as the default, but I've just given it here. Okay, so let's go to the terminal and let's try to run this, right? So let me go to the directory where this code is present and let me try to run this. So it's as simple as just saying Python hello flask.py. Okay, so let me just clear it. So as you can see, our application is deployed, right? So now we have the ping application ready. All we have to do is go to this endpoint and see if it returns POM. So let's see. Let me open a new terminal. Go to okay. So now we have two ways of interacting with this application, right? So we have the endpoint running on this port, right? So now we can either go to the browser and call the API, or we can use something called curl. So curl is an inbuilt functionality which allows us to talk to endpoints. So we're going to use that. So the default is HTTP, so we don't have to mention that. And we're going to use the okay, this wouldn't run because, yes, why would this not work? Because we have not given /ping, right? So let me do a control C, and we have to do ping. Okay, so I think I have something running already on like my 5000 port. I think that's why it's creating this issue. So let me run the script again. So now it's going to work on 8501 port.
Uh, 8501.
Yeah. Because I've changed the address, I mean the port, but it still is getting deployed on 5000 port. Yeah, so I told you, right? Something is already running on my 5000 port, so it's kind of interfering with that, right? Okay, no issues. Let me quickly go to the slides. So. Actually, I would like to show you the prediction script, right? So now what we did with the Flask app was that we gave it a port, we gave it a local host, and we said it that, okay, if we go to the ping pink root, I want the POM to be returned. And okay, so let's say we try to run it with curl as well. So there's some problem with the HTML, right? The URL that you mentioned is not working. Yeah.
The start itself is not complete. Did you save hello class.py?
It gets automatically saved in PyCharm.
But it's not reflecting.
Yeah, exactly. Anyways, I think I can go to the Flask application that I have for the churn service, right? So for the churn prediction service, right? So I've written a Python script. So what the Python script does is it takes the data, it does all of the pre-processing on it, then we train a logistic regression model on that, and the model gets validated using cross-validation techniques. And once we have the best model ready with us, using the validation results, we take the best model. And once we have that, we go and save the model, right? So with open output file, so we just use this particular library called Pickle. So Pickle works very well with scikit-learn models. So there are different ways to save your TensorFlow models. There are different techniques, but we use Pickle here. So we use pickle.dump. So you can see DV and model. So DV is nothing but a dictionary vectorizer. Basically, in our models, we use scalars, right? Scalar to make sure that your features are scaled, like they're not ranging a lot. So we basically use some kind of a scaling technique to reduce all those features so that it's easier for the model to run and perform better. So we save DV and model. These two are the things that I already have saved, and you can see them here, right? So model _C is equal to 1.0 bin. So this is my binary file where my model is present. Okay. Now I'm going to write a predict script, right? Which is very similar to the ping pong script that you've just seen. And what it's going to do is, first, we import all our libraries, okay? We have already seen the Flask library, and we create the Flask app, right? Now, before this chunk, you see this particular code, right? Now, what this does is it loads the model, right? It loads the model into the current session. So we already have the model binary file present, and we load it and we have DV and model. These two are the ones which the model would require. And once we have that, we write the predict route, right? Now, once the consumer goes and types whatever the host name code /predict, okay? Now this, as you can see, this is not a get method. So now the user is not requesting for any data. Instead, the user is sending some data and in return expecting something. So that's why you use the method post. So once you use the post method, now this particular Flask request, right, it's going to wait for something to be coming from the end user. And what we have written is customer is equal to request.getJSON. So I've showed you the slide, right, of the diagram before, and we showed how the marketing service sends something to the churn service. Now, what are they sending? They're basically sending a JSON. Okay, so let's say they're sending a JSON with all the features of a customer. Like, let's say something like this, right? So they're sending a JSON, like the gender, if they're a senior citizen. So let's say a model is already prepared, it's already running, and the marketing service knows all these details about a user. Now they're going to send this to our churn service, and instead, so in return, what do they want? They want to see if this particular person is going to churn or not, right? So this is a JSON file. It looks very similar to a Python dictionary, right? It looks very similar. So in the predict script, what we're going to do is we're going to import an additional Python it's like a additional method from Flask. It's called request. This request is going to wait for a JSON file. And once it gets a JSON file, right, it's going to pass through it, okay, and convert it into a Python dictionary. So so once the user sends a JSON, it will convert it into a Python dictionary. And after that, we already have our scalar and our model loaded into the loaded, right? So we have it here. So we have already loaded it. So we're just going to do a transform on this particular Python dictionary. So it has all the features. It's going to transform it, scale it, and then we're going to apply the model on it. So model.predict probability. So most of the people who worked with machine learning before. So this is the function we all use to send the features into the model and get the output back from the model. And we are going to see what happens to the YPRED is basically the score that the model is given to this particular consumer. So if it's a high churn probability, right? So it will throw out 0.85, some kind of score between 0 to 1, right? So the range here we have defined as 0 to 1. And if it's very, if the threshold that we have decided is 0.5. So now this is up to the data science team. They can decide what kind of threshold they want to give. And above this threshold, if the score goes above this 0.5 score, they are going to send probably a promotional email saying that, you can convert and stay back with us. So this is something which we want to decide, not the we don't want the marketing service to do that. So we are already putting this as a hard-coded thing in our script. So ideally in the production environment, I wouldn't hard code this. I would make it as a parameter and allow us to change it as the business use case wants it. And once the churn has been defined, we know the churn is a bool, right? It's either 1 or 0. And we have the prediction score as well. So now we want to send this to the end user back. So we're going to send the result as a JSON. So JSONify is another method which converts your Python dictionary back into a JSON. And this is what the end user is going to see, right? So they're going to see these two fields coming after they call the API. So we are again running this particular script. That's why I'm saying my name, the name is equal to main, and we are running it on the port 9696. So port 9696 is not already taken. So let me go there. So this is a different, so I've deployed all this code to GitHub, right? So you can access the code there and clone it into your computer and also play with it. So we have predict.py, right? So this is the file that we're interested in running. Okay. So before I run this, you're going to see me do something here, which I'm going to explain in a little bit.
Sony, is there any reason why you have duplicate type conversion in result dictionary?
Sorry?
Is there any reason why you have a duplicate type conversion in result dictionary? Like if you see the churn variable is already a boolean, you are trying to convert again in lagging 20. It is a float, right?
Yes, exactly. Yes, it is a float.
Churn, if you go to churn, there's a YPRED is greater than or equal to 0.5 is a boolean, right? True or false?
Yeah. Python Boolean.
Python Boolean is different. It's so when you run it without the bool, it would throw an error saying that like the value that we're going to get is not going to be true or false. Python works in a different way. So let me, if I remove this, right?
Again, can you set for line 28 because the dictionary will be translated into a JSON.
Yeah, JSON will convert. Actually, in Python, Boolean will be like The first letter will be capital, right? The Boolean if you print it out. But in JSON, it will be just all smaller things. Like it will, when you convert JSON file, it's going to make it
As a small, all lower cases. Okay, okay. So when you basically run it without,
I think it should work without conversion.
so you see me, I've entered some kind of a pip environment, and I'm entering that environment to run this particular code because all my dependencies are inside this virtual environment, right? So I'm going to explain that in a minute. So I've entered, so as you can see, I've entered a new environment, and let me just run the model here. So Python, I'm going to do predict.py, which is running the current script. What this is going to do is it's going to load the model, and it's going to make it available to us on this port, right? Shouldn't take this long. Ah. So when I'm using pipenv, right? Pipenv is a version, like it's a environment manager, and what it helps you do is it's like defining all the libraries that you need for your particular project. You just have to give it specific versions, and it will create a virtual environment for you. So now when you have pipenv ready, it creates these two files, pip file and pip file lock, right? So I already have that, but it's very easy to generate them automatically. So now we're just going to go into pipenv shell. So if you want to pipenv shell -- system, it's already activated, right? Okay. Okay, so we have the model up and running on this particular local host, our own computer, on the 9696 port. So what we're going to do is we are going to run our another script that I've written, right? So that particular script is going to so that script is going to send a JSON, and it's to this particular API that we have generated now, and we're going to see what it returns back. So let's go to our environment. So we have churn Flask, and let's test it there. So we have Python. So this is the predict test.py. Let me show you how the script looks like. So we are just importing this library called requests. So requests helps you communicate with endpoints that have been generated. So any kind of URL that you have, you can talk to it using requests. So we are just passing in a JSON saying that these are all the features of the consumer, right? And we're going to do a request.post. So post, you see, is the type of the request that we're sending. So we are telling the API that we are sending you a JSON. That's why I'm saying a post. And then I'm passing you this JSON that is called as customer. And then whatever I'm getting back is also then converted as a JSON type, right? So that's why I'm using .json here. And if whatever the response is going to print it, and if the churn, which we defined as a Boolean, if it is true, we're going to see this particular print statement popping up. So let's see if this works. So we're going to run this. Yes. So you can see now what is the terminal return. So we ran Python predict test.py, right? And we sent it a JSON. And now the service, which is up and running on 9696 port, it's saying that it's ran the model on the customer and saying the probability that it might churn is only 0.32. And this customer might not churn for us. So let's not send a promotional email to them. Okay. So let's play around with the JSON. Let's say if the tenure is just a month. Okay. And I'm changing this as well. Okay. And let me run the script again. So it's going to make a request again. Now what happens? Now the model is predicting a different probability. It's saying that this customer is very likely to churn. It's above 0.5. So the churn has turned out to be true, right? So we're going to send a promotion email to this particular customer ID. So we just saw how we could communicate with a Flask generated endpoint, right? So it is all a simple, like a Python framework. We just saw how we could call the app, just define a route. And inside this particular thing, we have called our model. And usually best practice is to put this inside another function and then just invoke the function here. But I'll just put it here for the sake of simplicity. So in the production scenario, I might probably put this in a different class and call it here. Okay. And so we have just written a very simple Python structure which calls a model, and it's available on this particular port, and anyone can now interact with it and interact with the model, and we're able to get the results back from it, right? Now, we cannot do this from a browser because to send a JSON through a browser, it's pretty difficult. So that's why we wrote another script called predict test.py, which uses the request module to send the request. Okay, so now this was a simple introduction to how Flask works. And there are numerous ways you can use Flask to create your web service. Like I've just created an endpoint, but you can plug in a SQL database, whatever request that's coming in, you can log them somewhere. You can also do multiple things on top of it, write a HTML kind of interface and return that interface, right? So you can also do something like this, right? You can create some kind of a HTML like this, okay? It's a very simple HTML code. Give a title, create these fields, and you can enter the values here, and you can see what the churn output is. So these are things that you can develop on Flask, and it requires some kind of front-end experience. You need to know HTML and all those things, right? So once you can define that template, you can ask Flask to return that. So, okay, so we saw how to wrap the predict script in the Flask app, and then we saw how to query it with requests. So once our endpoint was ready, now preparing it for production. So did anyone notice that while we were running it, did anyone notice this error?
It said it's not production ready.
Yes, right. So it said this is a development server. Do not use it for production. And you can also see the 2 post requests that we sent. So Flask also has this inbuilt way of logging the request that comes in. So why does it say this? Because Flask, the web server that it uses under the hood for handling the request and sending it, right? So that that is only meant for a few days, or maybe if you keep running this, right, it cannot handle it for a very long time. You cannot just run this for a month or something. So you need some kind of a more powerful production server to handle that. And if you don't want to see this this error, there is a library called GUnicorn, right? So that is a library which I generally use. It works on Ubuntu systems and Mac OS, but not on Windows. So for Windows, you can use something called Waitress. So what this particular GUnicorn does, it helps in now when you look at Flask, in 1 second, it is a single threaded process. It can only handle 1 request at a time. What if your app has to handle 100 requests at the same time? Okay, then the Flask would fail terribly. So that's why we need a production server, right? And we use GUnicorn for that. And GUnicorn works in a very simple way. Okay, so you just have to use, this is the, so you have the GUnicorn, and you use this local host, wherever the app is deployed, and you call this particular script in it, right? So let me just Control-C. Okay, so now we have, let me see if we have GUnicorn installed. Okay, so it's already installed in my environment. So we just have to run GUnicorn, and then we like as we mentioned in Flask, right? So the similar way, we just have to give the host name and the port name, and then what we do here is we say which script does it have to go to, right? So so predict.py is the script which has our application. So we are pointing it to that script, and inside that script, what is a variable? What is the application that you want to run? Which function which variable do you want to trigger, right? So we are doing app.run here. So we want to run app, right? So this is the thing that we want to run. So so you take it to the script, and then you say go to the app, and then you just run it here, right? So GUnicorn will not throw this error now. Okay, it's still, so it has generated the same endpoint for us, and it's a production ready server that you can use. Okay, so the predict or test would still work, right? But now it's listening to the GUnicorn service. Okay, so we've seen a couple of things here. And now let's go to the pip-env that I was talking about, right? So this is a best practice that usually any machine learning or data scientist has to follow. So we have multiple things running in our environment, right? So let's say I have this churn service model, and I also have a lead scoring model, and they're all existing in my in the same laptop environment. Maybe this model requires Python 3.8 and this one requires 3.9, and both of them require different versions of scikit-learn. So these are all different set of libraries. But if you have it running on the same machine, they're going to point to the same Python binary file. They're going to use the same Python to be running on that, right? So it's going to create a lot of conflicts. So if I want to run multiple services on the same laptop machine, I need a way to isolate. I need a way to make the system understand that these two are different. I need to have separate environments for both of these. So that's when pip-env comes into picture. Pip-env helps you to create a virtual environment. It triggers that, and now you see the directory below, right? For each of these models, when I just do a pip-env shell, I'm actually entering into a new environment that is specifically designed for churn service. It has all the libraries for churn service, and it points to this particular bin Python. This bin Python is now available inside dot local share inside. So it has created a new folder as such, and it points it to that folder for installing all our libraries. And that's how you ensure that you don't end up in resolving your conflicts, right? So so yeah, coming to that. So how it works is for pipenv, it's as simple as just doing pip install pipenv. Okay, so you just first install the library into your environment. I already have it installed. Okay, so once you have that ready, you just do pipenv install, and you give it all the libraries that you require, right? So let's say I need NumPy, and so I'm going to go to maybe the Hello Flask, and for this I'm doing a pipenv install, and I'm going to install NumPy and maybe pandas and Flask. Okay, so when you do pipenv install, and these are the three libraries that you have defined, right? What it's going to do is it's going to create a virtual environment for it, and it's going to install these libraries one by one, and it's going to create a pip file. So this pip file is where all your versions are going to be captured, right? So you see, for the Flask model the prediction service model that we just saw, NumPy was a general latest version. Scikit-learn was this particular version. And I was very specific about this because when I was training the model, I used Scikit-learn 0.24.2. So you need to make sure that when you're training the model in your development environment, you need to use the same kind of versions in your production environment as well. And I've used Flask and GUnicorn, right? So these are the 4 packages that I need. And this is the Python version, right? So you can define all those things in your pipenv install command, right? So I've now, inside my Hello Flask library, okay. Now let me just, so I have a pip file and I have a pipfile.log. So I have these 2 new files created. Right, so I have pip file and pipfile.log. So if I look at pip file, now it's going to say that all the packages have been downloaded from PyPy, and these were the 3 packages that we just installed, and this is the Python version. All of this is configurable, right? And then you have your pipfile.log. Now this file is actually a hash file. It contains every single package and what is the exact version of that, right? So now when you're running it in any environment, you just have to do a pipenv shell, right? And when you do pipenv shell, it just goes into that environment. And yeah, so because this is a virtual environment that is already activated, no action taken to avoid nested environments, right? So you're going to, you're just going to enter the shell and you're going to say, avoid this virtual environment, right? So you're going to, okay, my charge is, it's going down, okay. Is there a way you can charge my laptop? This is 9%. I have a charge of it. It might shut down. Yeah. It was on Docker, huh? Funny if it shuts down. Is it not working? Yeah, it's working, it's working. Great, okay. So when you see the PyCharm environment that I've created, right? PyCharm, when you create any kind of new project, it automatically asks you to create a virtual environment. And there are lots of ways to create a virtual environment, right? So you can select VN or something. So for my particular project, I wanted to put all my projects into the same folder. So obviously I went for VN. Now this is creating a conflict because I already have a virtual environment and I want to run my pipenv on top of it. Okay, it's creating a problem. It's not able to nest it, right? So we need to avoid that. And if you just Google, you'll find some kind of a command which helps you come out of that nested. It says that just don't consider the virtual environment. Let's go into the new shell and execute all our commands there. So this was a brief introduction with pipenv, right? So we saw why do we need a virtual environment because of these version dependencies and conflicts. And we saw how to install pipenv, how to install libraries with it. And now that you have pipfile and pipfile lock, you're good to go. When you just have these two files, you just have to do pipenv shell and it enters into a new virtual environment. And then you can run any command within it. Okay. Now, another thing that I spoke about in the earlier part of the session was Docker, right? Now, why do we need Docker? So if you look at this particular image, you see that we have, let's say we have these two models and we want to run them on the same machine. But now it's not just as simple as two different Python models. Let's say we have some system dependencies also. For churn service, probably I want to use an Ubuntu operating system of this particular version to 20.04. And because it comes with some kind of embeddings, and I want to go for a lower version of Ubuntu for my lead scoring service. Maybe I want to go for a TensorFlow library, which needs a G++ compiler. So this is a C# compiler, right? So maybe I need that, but I don't need it for my churn service. Now, because I have all these system dependencies now, I use Docker to isolate it. Now, what Docker helps you do is, it helps you put all your code files, your system libraries, anything that is required to run your particular application. It helps you put all of that into one place. And once you put that into a container, so we call it a container, okay? Once your service is packaged into a Docker container, now this container could be run anywhere. So you could take it to the cloud and you just have to do Docker run and give the name of the Docker file that you just created. And it would just spin up this service and your service would start running there. Now, we need that kind of complete isolation between two projects, right? So that's why Docker has been a key thing. And let me just show you how to run a simple Docker image, right? So let's say I want to run Ubuntu. How much time do I have? Oh God.
Hard to tell. How much time will it take?
About 15 minutes.
15 minutes, already 11:15, just check.
So what should I cover? I have
So you
something
just
interesting
cover.
also.
After that, we'll have a small break then. So is it okay if you start by 11:30 and all? Okay, then
No
you
problem.
continue.
Okay. Okay. So let's say I want to run a particular Python image, right? So I just let me go to my browser and let me type Docker Python image. What's going to show up? Okay. So let's go to the Docker Hub. So Docker Hub has, it's a place where you can find images for your services. So you see all these simple tags, and this is where we need to choose an image, right? So let's say I want to choose something like a slim version of Python. A slim version will have a lot less packages, and it's going to be less in size. So let's say I go there, and I just have to do Docker run -it. Python, let's say the image is Python 3.8. I already have this image pulled in. So 3.8.13 slim, right? So let me just do that. 3.8.12 slim. Okay. Unable to find it, so it's going to pull it locally, I guess. Is that the tag? 3.8 point? So you guys must be thinking how to install Docker on your laptop, right? So if you have a Mac or a Windows, right, I would suggest you to just download Docker Desktop. So just go to Google, find the DMG for this, Docker Desktop. And once you have that, now you can see I have all these images on my system. I've already downloaded, pulled all these images, and I have 3.8.12. So let me just run that from the system. So Docker Desktop helps you look at, like, manage all your containers and everything. It just comes into one place, right? So I have this particular image running now. So if I go to the CLI, now let me just increase the size. So what has it just done? Okay, so now I am inside a shell, right? Now this is actually a Python environment. If I just do Python, it's going to let me import any kind of library that I want. And as you can see, this is actually a Debian Ubuntu kind of system, right? So I have, now I can do anything that I want in it. I can execute Python commands. I can go out of it, right? Control D. And then now if I want to create a new directory, I can just create a directory. I can go to that directory. And if I want to install some kind of like a pipen, I can do that. Now, whatever I do here is going to stay in this environment, in this Docker container. It's not going to affect anything outside, right? So this is what. Now, let's say for our churn service, we want to define a similar kind of environment, right? So we want to install all the libraries and everything. How do we do that? Now, if you want to pass, so that's when you use a Docker file, right? So a Docker file is nothing but a set of instructions that you're given, and this is going to. So let me show you pull the Docker image here. Okay. So this is a simple Docker image that I've written. Now these are the instructions. So I just showed you how to enter into an image. So we pulled the Python image and it created an environment for us. We just entered into it. Now, if I want to execute certain steps inside that, okay, those instructions are written inside the Docker file. Okay. So first I'm going to define which base image I'm going to use. So this is the base image. And on top of that, I'm going to layer it with other instructions, right? So I'm going to say, I want to run this particular pipen library. I want to create an app directory, and let's go. So all of these things are happening inside the container. You go in, you create the app directory, then you copy your pip file log into the container. So when you do this command, it looks for pipfile.log in your system, and then it copies to the container. And then similarly, you run this pipen install. So -- system will ignore the virtual environments created and will deploy, it will install all your libraries into the system. So you run this, you copy all your model scripts and everything onto the container. Now you expose this port. So 9696, we export it so that we are able to communicate with the container. And then we run the gUnicorn. So this is a production server that we just saw. So you see, these are just simple set of instructions that I've created. And once you're able to create that, you now just have to run the Docker command, which looks something like this.
On your line 2, you're given 3.8.12.
Yes, yes. So this is 3.8.12, right? So this is something that I've chosen for my model. My model was developed on 3.8. and not 3.13, which you just showed. Yeah. So 3.8, so 1, 2, I can just ignore 1, 2 and just give 3.8 as well, right? So there are different images available and you can test out with that. And once we have that ready, all you have to do is go to your terminal and execute this docker build -t churn prediction.latest, right? So let me just execute that. So this will create an image for you. So if you go into deploy churn Flask, and I already have my Docker file ready, and I'm just going to do this, right? Okay, so now when I'm running this, okay, it's quite fast because I've already executed this before. But for you, it might look different. It might pull this Python image. It will install all the pip dependencies. And once you have that environment ready, now you have your Python image file ready, right? So this churn prediction Docker file is ready for you. Now, if you want to expose it to 9696 port, you have to run this Docker run. Okay, now what -it does it helps you interact with the container, and -p, you define saying that 9696 is the port of your machine, and you want to forward it to the port inside your container, right? So you're able to talk from your machine to the container. So that's what we do. So if someone tries to access 9696 from my computer, they would be able to, instead, they're not talking to my computer, they're actually talking to the Docker container. So we do a port forwarding here, and then we just type the image that we just created, right? So let's do that. So when we do Docker run, now you can see our GUnicorn is started. So now my endpoint is available, and this HTTP 0.0, this localhost endpoint, is running inside the container, right? Now, if I want to access it now, let's run the predict test script again. Okay, let's run the predict script again, and it works, right? So now this script is actually listening to. The script is actually listening to this particular endpoint, right? But this port on my machine is actually talking to the container. So my model is actually is deployed inside the container, and we're talking to that, right? So this is how you deploy a simple Flask API inside a Docker container. And now I was talking about, in the previous slides, I was talking about how to design a user interface and all of those things, right? And how you need a HTML background to do it. But then I found something super interesting and it's very popular inside the community. And I wanted to share it with all you guys. It's called Streamlit. I don't know how many of you are aware, but it's a very popular service among the ML practitioners. And it's basically a Python library, and it helps you build interactive UI components, all using simple Python functions. You just have to pip install Streamlit, and then you have to call. You just have to call certain. If you want to create like a box, you just have to do st.box. If you want to create a slider, so they have all these inbuilt functionalities, and you can get started with it very easily. And you can also deploy or host your app for free. So Streamlit has this amazing thing that they're doing. You just have to host your app on GitHub, put all your code on GitHub, and then you'll be able to deploy your app for free. Right? It has super cool features. And if you want to run Streamlit, right, let me show you that script as well. So for the prediction service, I have written something like this. Okay, so just keep in mind, guys, I put all this code on GitHub, so you can access it after you're done with the session and try to just see what I've written here, right? So I've defined a lot of things, and I've given sidebar. You could see all these lines, the text here, and I've put a select box, right? I've given all these different UI components, and it's as simple as just declaring it, right? You don't have to write any HTML script whatsoever. You have the input dictionary ready, And then you just call your model here inside some kind of inside. If this button is pressed, you just do this and you return this, right? And that's how simple it is. And when you run this, okay, so let's say we want to run this, it's as simple as just doing streamlit.run, right? So now, so let's say now I go back to my Streamlit repository. So I go to deploy churn Streamlit. I have all my requirements already set up here. So I'm just going to go into the pipeline shell. Streamlit run. What is the app name? Oh, Sean prediction. I just have to do streamlit run streamapp.py. Okay. Yes. So now this would probably come into error because my pip file, right? I've tried to do pip and shell, but it's not entering into the virtual environment because of the nested environment problem. I'm just going to quickly show you a way to deploy it using Streamlit's own service, right? So if you just go into your browser and go to this particular, let me go here. Okay. So there's something called share.streamlit.io. Just go into this particular address, and once you go there, it will ask you to log in as a with your GitHub account, right? So I just logged into my GitHub account and I have it already up and running here. So what I did was I just deployed my app here. I gave the repository and it had all my requirements file and all those things. Streamlit was smart enough to recognize all of that. And now my app is deployed, right? So I can just, so now this is the URL link, which all of you can also access. And so this churn prediction application service with the Python script that you just saw here, okay, it's going to result in something like this. And it's open to everyone, right? So this endpoint has been throw in error. Okay, so you see, I gave all the select boxes, right? So Streamlit, so select box would look something like this: male, female, 1, 0, yes or no. So you could do all those things. And if you want to change like the months here, you could enter something like 45. If you want to, like, it can also, you can also provide, give these thresholds saying that, you know, you cannot go beyond 240 or whatever. So you can give that. You can also change something here and then just run the predict script, right? So now I did all of this using just simple Python, okay? And we deployed it using using Streamlit's own service. But you can also write a Python like a Docker file for Streamlit as well, and then you can just export it anywhere, and this particular application would run for you, right? So let me just quickly summarize everything that we have just seen. Okay, so first we saw how do we use Pickle to save our model, right? We have the model in our Jupyter notebook. How do we just bring it and save it somewhere? Once we have the binary file with us, how do you make it as an endpoint? How do you expose it as an endpoint? And we use Flask for it. Okay, once we had the endpoint ready with us, we were able to talk to it. And how did we talk to it? Using a request library. We just sent a request, gave a JSON file, a JSON object, and we got the prediction also as a JSON. So we tested the application and we used GUnicorn for those production facilities over there. And then we packaged the application using Docker. right? So we isolated everything. We made our service isolated from everything that was available on the system. We packaged it, and now using Spring Boot, we also designed a user interface, okay, using simple Python. And once you have that Docker file ready, now you're good to go. Now you can go to cloud, AWS Beanstalk, Elastic Beanstalk, container apps. You have Azure Container Apps, Azure Kubernetes service. Okay, just take your Docker container and put it anywhere on the cloud and ensure that it's production ready. Right? Not just cloud. If your company has its own servers and you have your own data center, right? So you can also deploy it over there. It was important for me to show you how this journey of getting your machine learning model to a Docker container, right? So once you're there, it's easy from there on. Yeah. So that's it, guys. That's it from me. And if you have any questions, I'll be around here. So just come and ask. Yeah. My GitHub link, right? Sure. This is the link. You can find me.
Please assist if we need some 10 minutes break. There's also a both sides if you want to. So then we can start. Yeah. Yeah, so thank you so much, Sonia.
Okay, thanks.
So,
There are a lot of questions on Zoom as well.
yeah, that you can answer in the chat.
Yeah.
Or if they want, they can unmute and they can answer.
I can answer it. Oh,
Please take
thanks.
this.
Thank you. Thank you.
Usually they usually ask a question without given a gap. But it was very good. From the basic, it is covered everything, like deploying different.
I would have wished to have some more time to go through the code one by one. And
We may need a break, right?
we may need a break, yeah.
Yeah, please take 10 minutes break. For that.
Hey, hi. Answering on
Like the questions.
the questions, right? How do I do it? Just unmute it, right?
So the live stream is off. Live stream is off there.
I'll just reply to them on Zoom. Yeah. Just a second.
Can I connect to power now?
Sure, sure. Actually, I was presenting using Zoom. I was sharing my screen on Zoom. And then, yeah. Sorry?
Unmute.
No, I logged off. I mean, I left my meeting. Okay, okay.
Thank you so much for being here. So I'm Anindran Krishnamurthy, volunteer of TFUG Chennai. So it's a pleasure to have David, who's an enterprise architect with around 24 years of experience in multi-matrix. So we request David to start the session.
Yeah, let me start. Let me know if you all can hear me actually from the back. Okay, great. So let me do one thing. So how the session is going to be is like, it's going to be a presentation as well as, side by side, I will start a demo because what might happen is the demo will take some time. So I will be starting in parallel, but we'll go back and cover some of this session in parallel actually. So that way, no, I won't take much time, not more than 1 hour actually. So I'll try to wrap it up in 1 hour and, give me a sign if you are seeing it running more than that. Okay, so the session for today is like, the first session covered a lot. I think it set you up a good platform to understand what is a machine learning model and how do you develop it, all those things. So let me break it down into this session into, based on the topic itself. The topic is Introduction to MLOps using AWS SageMaker. So first, let me introduce what is MLOps, and then let's see how we can do it using SageMaker. Right? SageMaker is a platform. I'm not a advocate of AWS, but at the same time, what I want to show is how we can deploy models in the cloud and what's the benefit of it. And you can use any cloud platform to your liking and what your organization gives you. But at the same time, we today are going to use AWS SageMaker to give how things work on the cloud actually. Okay. Let me introduce what MLOps is. Okay, so you might hear all these fancy terms: DevOps, data dev, SecOps, all those things, right? So whenever you hear these terms, these things happen after the things exist actually. The naming comes later because these things, it doesn't fall out of cloud, one fine day and suddenly new thing called MLOps came. All these things existed, like the Earth existed and then you name it Earth, right? So likewise, the practices existed, but it got formalized later and got this fancy name MLOps, right? So, and again, to just to break it down, unpack it a little bit more, MLOps will divide into 2 parts, right? So what is ML and what is Ops actually, right? So, and ML, I think in the morning session, we had a lot of talk, right? And how many of you are ML engineers here? Or just, heard this term, it's fine. No, everyone is learning, right? So, so ML is half the way, So whenever you see these fancy terms, try to break it down, okay? So what is ML? Like when you see DevOps, divided into half actually. What is development and what is operation? So, and people always make things short. So they, machine learning, they put it like ML, right? And operation, they put it like Ops, right? So, and ML is machine learning, Ops is operation. And what do you mean by operation basically, right? What if I want to make something operational, what is it? More like, making something useful, right? So ML is building the machine learning part. Operational is you can think of making it useful or making it consumable by others actually. So whenever, let's say you buy a TV, let's say, I'm not that rich, I'm not buying anything recently, but if any one of you are buying recently any television set, it comes to your home in a packed manner, right? So the TV is already built, but it's not yet usable actually. You need to install it. You need to do the plugging and you need to do that kind of groundwork you have to do to make it usable or operational, right? So probably next time you see a TV installation person, you should call him a TV ops guy, right? So you can make those fancy terms. Okay, so that's basically, take a machine learning and make it operational. That's it. No, there are many fancy definitions to all of this, but I am telling the most practical thing. Now, when somebody asks you what are you? I'm an MLOps engineer. You are going to tell that somebody built a ML model and I'm trying to make it useful. Okay, so that's the whole idea about it. Okay, let's share about it. Okay, so I'll go to presentation mode. Okay, so just a brief about myself. Okay, so I'm not going to take too much time, maybe a couple of seconds. So my name is David. I have close to 24 years of experience. Primarily, I'm started my career as a data developer, then data DBA, and then data architect, then into machine learning and cloud. So it's been a very long journey. Sometimes interesting, sometimes not so much. But overall, this is my overall. I primarily specialize in data, and I wouldn't call myself an expert. I'm still learning many things, and most of the people might be learning, especially in this area. You have to keep. Somebody is expert. If somebody says I'm an expert, it's not actually, right? So you keep learning things, and and I've done certification, as you can see, and that's part of the learning journey. So last 2 years, I'm pretty much focused on machine learning and machine learning operations. So primarily, for the primary idea of making things usable, right? So one part is theoretically, many things, you talk things, but what's the use actually? Like if it's business is not using, it's not very useful. No, you build many POCs, many applications, but end of the day, you have to make it useful to the business. So that's the idea of MLOps. So that's why, my passion shifted towards MLOps, trying to see, make things useful. Okay. So that's a short intro about me. You can connect me on LinkedIn, by the way, right? Okay. So this is, I think this was covered last session, but I'll quickly go through it. So this is a model development lifecycle. You might have heard of software development lifecycle. And this is typically, model development lifecycle. And if you see model development lifecycle, many people are involved. It's not, there is no single term. Like maybe people always think, what's my role in this whole journey actually? All this talks about MLOps is fine, but where I do fit into this, right? So you see, it starts from data engineers, basically. So everything starts from data because all this is whole area, which is primarily data driven. Okay, machine learning is a data driven operation. So it starts from data engineers, then it takes the ML builders or MLOps, ML architects, MLOps architects, they take it over. And then, data scientists also play a critical part. And, there is a DevOps engineer, okay? And there are software engineers, there are testers. Obviously, there will be some project managers, Scrum managers, all those things. So it's a plethora of unit actually. So all these people get involved in this actually. So I'm not going to go in detail into all these things, but I want to highlight is like till this part, I think it's all clear. Like, you do the development, you play around, you experiment, but this is where the MLOps starts to kick in actually. So how do you take this from a development stage to the usable stage? And model also you cannot just like that deploy, because let's say one model is working tonight, tomorrow normally happens, you out of your curiosity or your interest, you push another model. And next day onwards, your phone starts non-stop ringing actually, because what's all their performance drop, all your model metrics drop. So there is a way to promote code actually. So every single change, has to be rightly implemented. So that's where MLOps play a great role actually. So you deploy and then you register the model and take it to deployment. And after your deployment, the process doesn't stop there actually. You have to consistently monitor your model performance, right? And then come back and retrain and relearn. It's like our human life only. It's like it's going to be a cycle. So that is where this particular piece is very crucial, right? Okay. So what is the rationale for MLOps actually? So I believe we we talked a lot about MLOps. There is the rationale. So deployment and management, that is one of the key important thing, right? Because what's going to happen? This deployment process is going to be hectic. If you are not using MLOps and you are trying to do an ad hoc deployment, initially for one model it will work fine. 10 model, it will work fine, but your model base is going to grow. Then this becomes a very, time consuming and very chaotic actually. So that is one thing. And there is this concept called data drift and model drift. Okay. So what is data drift? Okay. Let's say you train your model using housing prices. Now, let's say you want to predict a housing price. And let's say you want to use a data set before 1990 or 2000, and you train the model, right? 1990, the prices of Chennai and all will be somewhat in a different range actually. Using that, if you try to predict, you will predict Adayar areas 10 lakhs or something, right? So that will be a disaster actually. Somebody, takes 10 lakhs and go to buy a flat in Adayar. They are not going to, be kindly welcomed actually. So that's where, the data of one time frame may not be suitable for another time frame. So your data is drifting, right? So that is a data drift. What is a model drift? Model drift is something like, your model performance degrades over time actually. So it's not like you created a model, you start predicting and, then all is going to be working fine, So the model over a period of time is going to do some degradation. The performance metrics will come down. So what point you have to do the, retraining of the model or redeployment of the model. So these are some of the things like I said, training loop, artifact tracking. So that is one of the key things. Every single process, your Docker files, your performance metrics, everything is going to be tracked actually. Without a proper MLOps framework, these things are not going to be tracked actually. Somebody asks you, data scientists normally have this query. Hey, my model ran well on April 23rd. After that, someday this model started failing actually. So what did you have as on that particular date? What are all your artifacts? Which data you used to train? And which model, which pickle file, right? You uploaded. So this artifacts has to be tracked actually. If it is not tracked, it's going to be operationally, it's going to be a large issue actually, right? So this is actually, going to be the key things for machine learning ops actually. So this is where the rationale for it. Okay, so like I said, there are key actors: data engineers, data scientists, ML engineers, software engineers, all those people, right? So, so I have mentioned, some of the critical things which has to be used. I'm not going to go deep into this. So meanwhile, parallelly, I'm going to start AWS session. So likewise, your model always, gets to deployed somewhere, right? So one option is on-premise, other is cloud. And cloud, you have various options. You have AWS, you have Azure, you have GCP. There are various options. And there are some new things coming up like Databricks also. It's not new, but Databricks is a key player in data, but now they want to do the ML flow also. So these are the various options you have to use MLOps, okay? And like I said, AWS is one such option. Yeah, sorry.
How about edge deployment?
Sorry.
Edge deployment, like on the mobile device, we deploy models. Right. Private edge cloud.
Yeah, so models on edge and models on lightweight devices. Right? So SageMaker has a capability called SageMaker Neo. only intended for devices on the edge and handheld devices and low power. So there are options to that. But today I'm going to be covering about the general SageMaker. So SageMaker is kind of a build, train, deploy framework which AWS provides. Okay, so normally you build a model in so build, train, deploy. What do I mean by build, train, deploy? In morning session we found that we are building, right? So it can happen in two places. One thing, it can happen. You can do it manually and at your own premise, and then you promote it to code. Otherwise, you can do everything in AWS. That is another option. So all pieces are isolated, and it can be done independently at any level. So I logged into SageMaker, right? And I logged into AWS console. Sorry, I am not showing. How many of you have AWS account already here? Okay, cool, excellent. Great. So the first thing what you do when you have a AWS account, it's a very important question actually. The first thing you have to set your billing alert, okay? Because otherwise it can make you really poor actually, right? So if you you go to your thing and there is this billing dashboard, go here, set a threshold. Whenever you are trying to play around with SageMaker or any such advanced features. Normally EC2 instance you can spin up and close it, right? But if you want to use some graph database like Neptune, or if you want to use a machine learning model like SageMaker, right? And you keep it open, right? It can make you really poor actually if you want to continue in AWS, right? So to avoid our poverty, just click the billing service and put a threshold to it. So that is going to be a first step. So I'm going to open SageMaker a little bit now. Okay. So SageMaker has this, on the left-hand side, if you come to this panel, it has two parts. One is, these are all development-related things called SageMaker Studio, and where you can actually do the development using Jupyter Hub Notebook. So, and also, once you are going to productionalize, you will be primarily working in these areas actually: ground truth, processing, training, inference, edge manager. Somebody asked edge, right? So this is where you can use this. You can patch edge devices. You can install here and you can deploy the models on edge. Okay. So, but I'm not going to talk these things about today. What I'm going to in turn talk is more about this area: processing, training, inference. Okay, these three things, right? And to do that, let's go to Studio. Okay. Okay, normally when you want to set up AWS, right, it will ask you to set up a domain actually. So I already created it, but it's not it's just click, 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 and you basically what AWS does is it creates some of the information where is your default S3 should go, all those things it will package, and you have to create a domain in order to use SageMaker Studio. Okay, so now I already created it. So I'll just launch app. Studio. It's going to take some time normally. Yeah, so it will create you Jupyter Lab basically, right? And and it's a very rich development platform. This is called SageMaker Studio. And I'm not going to run too many things onto this, but primary things are, it is integratable to Git, right? So whatever code you develop, you can directly use this place to integrate to Git. And then, it gives you many jumpstart models actually. So it gives you multiple models, let's say you don't have to start from scratch, because most of these machine learning problems are already solved problems, okay? You can take somebody's problem and then you can adapt it, okay? You don't have to start every single code from hello world, right? So you can instead use the existing thing and adapt it, right? So if you come down here, it's going to give you some options, right? So it is going to, it's quite integrated with the data flow. So you can integrate with data services in AWS like Athena or Redshift, that kind of thing. And you can export data into, from Snowflake, you can see, import and export data. And feature store, that is very important thing actually. Whenever you are training models, you do feature engineering, and that output of feature engineering will go into something called as feature store. Why that is important? Because you don't want to run your model again and again doing same thing. Because whenever you are training images and deep learning models, it will run half a day or so. So if you computed all the features and suddenly your training snapped, right? Oh my God, I should not start again. So another 5 hours of effort. So rather I will pick up from feature store because that part is already done. So you can start from feature store and you can run the model. Okay, so that is this feature group. And this is something called as autopilot. That is something, a good experiment you can do. You don't need to have any idea of any modeling, right? So you don't know whether to use XGBoost, whether to use, logistic regression, whether to use, some other deep learning model. You can issue your problem to autopilot, and SageMaker in turn will run in background. It will give you 5 to 6 models. It will tell out of this 5-6 models, this is apt for your particular problem actually, right? And this is particularly useful when you want to benchmark something. Let's say you are given a new project and somebody asks you what is a good accuracy metric? How do you define a good accuracy metric, right? This is a normal problem from data scientists. Generally, they ask, okay, I have my model, but how do I know it's good, right? And normally ML engineers tell whatever I say, it is good, right? So instead of that, you can normally tell, okay, I have this autopilot running, and this is AWS is giving such number, and now instead of I giving you an arbitrary number, you can compare this benchmark against something else. Okay, so this is very useful in that regard. Okay, so now what I'm going to do, I'm going to use a some kind of templated example only, so which is provided by AWS, and then walk you through the steps so that your typical coding experience will follow similar pattern actually. So it's not going to be any different apart from your individual code, right? So what I'm going to do, I'm going to select this. Whenever you also want to play around, select this one. And like I said, first thing is billing alert. Second thing is this, okay? Model building, training, and deployment, okay? Select this. So let's name it. Okay. Now this project will create actually, right? So what's going to happen? What we are trying to do is we are going to demo of build, train, and deploy. I think somebody on the Zoom has to go on mute. Okay, let it create. Meanwhile, I'll just go back and do some slideshows. Okay. Okay, this we already talked, data drift and concept drift. Okay. The concept drift is another interesting thing actually. Concept drift is a new terminology coming into picture actually. So which may not be available in the old terminology. Let's say smartphones, for example, right? Smartphone is kind of a recent usage actually. Most of you guys are young, you are grown up with this environment. Guys like me, phone itself is a big thing actually, right? We started from dialing this phone and then a brick-like phone and then, this smartphone, right? So smartphone in the older terminology doesn't matter actually. It is like, it is an unknown term basically. So it's a new concept, right? So so that's called a concept drift. Okay, so today's smartphone is there, tomorrow that might be something else, right? So that smartphone as a concept is oblivion, right? So that is where to handle this concept drift also, we need the machine learning MLOps framework. Okay, so AWS has a capability called Model Monitor, which can handle this. Okay, so this is something about model training, what is required for training, and evaluation is very important actually. So that is very key step in promoting model actually. So on what basis you promote your model? You compute the accuracy metric, and then based on it, you take a decision whether to promote this model or discard this model. Okay, this is all like standard things. Okay, I'll come back to here. Let's see, meanwhile, there. Okay, so looks like our project is successfully created. Okay, and what we can do, so it will give you two paths. One is the build pipeline and one is the deploy pipeline. So you see there is a build pipeline and there is a deploy pipeline, right? So, and what you can do, I'm going to clone this repo to our local. Okay, cloning is done. Okay, let's walk through this cloning part, the code itself a little bit later, but what I want to show you is, now it would have automatically kicked off a machine learning pipeline. Okay, let's see. So there is a pipeline which is being triggered now. Okay, so the pipeline is executing, it is already triggered. Yeah, this is what model we are training is something called abalone data, which is AWS. AWS is big fan of this data, so all their example will have it. So abalone is kind of a shellfish, and the model is it's a regression model basically. It is trying to predict age of the shellfish given some parameters. Given some data, it will try to predict. Okay, now you see, you can see a graph view of this, what is happening behind the scenes. So there is a pre-process, and pre-process steps are like, all your outlier detection, all your, missing value imputation, all those things happen in the pre-processing. Then your model training will start, then your evaluation, then you check the evaluation whether to promote it or not, and then you register the model in the model registry. So this is one particular graph actually. So once this is done, we will take it and deploy it, right? So this will run for some time. Let me see. We'll go to the pipeline again. So it is executing. So this is a graph view. You can also see, yeah, there are so still it is not created any endpoint or something because model is still running. Now let me try to go to SageMaker now. So like I said, I told you this part, right? Which is on the left-hand panel. Now it should actually create some processing job. Okay, so if you see, there is this new processing job which is being triggered actually. So this is actually a pre-processing job, what we showed in this particular window, right? So this particular window, and that graph. So we told that this is a pre-processing step, and you can already see that pre-processing running in the background actually. Okay. So after this pre-processing is done, there will be training and so it's going to take some time, but this is a typical graph view, so by which you can actually determine where your steps are running. So, and all these artifacts are tracked actually. When you take a pre-processing job, let me go to a pre-processing job. So if I try to click this pre-processing, okay, right now it tells it's completed. So pre-processing is done. So you can see the status here, and some important things I'll show you. Okay. Okay, you see this processing image, right? This is something by default AWS does for us in the background. So in the morning session, you saw you creating a Docker image, all those things, right? So you can bring your own container, or you can simply use AWS provided container. Okay. So in this scenario, we are not doing anything. AWS behind the scenes creates a container for us. And like I said, there is an instance count. You can scale up, scale down, all those things you can do actually. So in your code, you can dynamically increase the instances, and type of instance you can increase depending on your load. So this is one key thing what you can see, like this instance type, right? This is all configurable. On the fly, you can change it. Okay. And likewise, you come down. Okay. Yeah. So you can view this metrics also, like this is your system metrics basically. Okay, so you can see this, EC2 related metrics. You can also see some of the instance metrics also. Okay, so let me go back to this. So you can see metrics. Let me also see this. Meanwhile, we'll keep an eye on this job, right? Graph. So ideally, it should show the pre-processing. It will take some time to reflect that. Okay, but we already found that pre-processing is already done. So once pre-processing is done, let me see if we can go to that. So pre-processing is done, and we know that some training jobs should have already kicked off, right? Yeah, I think it's training is also done. If you see this is the training, right? So pre-processing is done, training is done, and training also you can see a lot of information in this training, right? So, but before that, let's go to SageMaker Studio again. Okay. Yeah, now it is reflecting, right? So it has completed pre-processing. Now it has completed training. Now this evaluation step is going to run for some time. And after evaluation will take some time basically, because evaluation step is the one which is going to compare whether a model is good enough to be promoted to next step actually. Okay, so that is the purpose of evaluation, right? And you can also get into this, zoom into this particular Okay,
Starts there.
I think it's done actually. So I think it got scared of hyperparameter tuning, I guess. Okay, so, so this hyperparameters, right, is something like, any machine learning model, you want to identify right set of parameters. These are some performance knobs actually, like in olden days TVs, right? Like I am not sure you guys know it. We used to tune something like, to, hey, some dots are coming now, 4 dots are coming now you get the picture, right? So it's something of that sort actually. So you basically tweak your model in such a fashion that for this set of values, I'm getting this set of performance metrics, okay? And sometimes this plays a very key role. And this cloud models like SageMaker and all, they provide a specific unit called hyperparameter optimization component, okay? Otherwise, scikit-learn provides like something like a grid search or something, So you can also use that to do it in a conventional fashion. But at a very large scale, those things are very slow to run actually, okay? So normally what we'll do, we'll use something kind of a cloud-based hyperparameter component, because that will also be running very fast and will give you right set of hyperparameters. So you see now these all things are trackable now. Okay? Previously, if you do this as a standalone, yeah, you might get your prediction, but you will not remember to what set of values you got this prediction. So sometimes data scientists come up with these kind of weird questions actually. So they will tell, okay, what did I set for one fine value actually? We cannot know without logging it or tracking it. We don't know. We can tell for recent runs, but let's say they go behind a date. Okay, May 23rd, 2022. What was the particular values I ran? No, so that kind of granularity is very important to capture, and that's what we are doing here. So let's wait for some more time. I think. Yeah, I think, now you can see this, all these steps are done. And now let's zoom in on this evaluation one time actually, right? Let's see. Or let's go to the next one actually. Somewhere evaluation should have it, I guess. Yeah, normally it should, if we capture the metrics, right, it should actually throw what is the root mean squared error for this particular model actually. So all those parameters are viewable. It should be here, but I have to watch it a little bit slowly. So yeah, now you can see the job is succeeded, right? So you can typically track this, operationalize this one, and you can actually see this job is done. Now let's take one more thing. Okay. So it should have created something called a model group now. Now we are ready to a stage where we are planning to promote this model actually, right? So you see now it has come to us, it has created a model group. And so there is something called as endpoint creation. No, so that has to happen. But before that, we have to model has succeeded. I go to this model group. Okay, I see this model version, is in pending status actually. If you see this one, because why it is pending status? Because in our code, we are not automatically promoting the model actually. So what we are doing is we are creating a human in the loop actually. So this particular code is creating a human in the loop where we have to manually approve whether this model can be promoted and created an endpoint. So you have to click this version. Okay. So, and you see this status is currently pending approval. Status is pending approval. Now I have to go here. I said I approve it. So I'm playing the role of data scientist here. So I'm telling, well, I have verified all this model. No, I'm seeing it is approved, and tell that no, RMSE is acceptable. Right? Then I update the status. You see automatically, now the status it will approve, and it is actually going to create an endpoint now. Okay. So what's going to happen? So this is the stage where I have to show you that MLOps also needs to talk to DevOps. Okay. So that's another fancy term. Like I said, you have to split it two ways: development and operations, right? Like so it is. Anytime you get a fancy term, just split it. It will become more simple actually. So let's see. I will use go to AWS console again, and in the services, so this is called a code pipeline service. Okay, so this is AWS provided DevOps pipeline actually. So you can very well change it to a Jenkins pipeline or some other pipeline. Okay, so but AWS example we are using, so let's stick to that one. So this is actually a, so you can see this one, right? So now this is all our model build thing is completed, and so next it is triggering our deployment phase. Okay, so it is going to a deployment phase. Okay, so it will deploy something. No, it will deploy. So all these things are some DevOps related activity. No, if you are an ML engineer, don't worry about this part actually. Okay, so if you talk nicely to your DevOps engineer and take him for a coffee, so he will handle this part actually. So you don't have to play all the things, right? It's not practically possible. Okay. If you're a DevOps engineer, don't worry about ML code. Okay, so be nice, be friends to each other, and sort things out. So this involves like CloudFormation template and other things, right? So, so what has happened now? We are trying to deploy the infrastructure and create an endpoint. Okay, and that will happen in background. So you see all this build is succeeded, and all the nice messages you see all greens. Okay. So whenever you see greens, like time to go back and check here. Yeah, so it should come like here. So this is going to be your consumption point actually, right? So all your, you need to protect this point only. So it's, in fact, morning somebody told he's a security engineer, right? Somebody working on security side. You right. So so for you, this is very important point actually, like because now we are reducing the blast surface actually. So you don't expose many things, So all you have to do is protect this endpoint, Whatever is going to be created, this endpoint will become manageable. So it is like very easy for people to go and protect the blast radius. It's limited to this endpoint. So if you see some attack coming in, all you have to do is turn this off actually. Okay, so because now all the things are handled at this layer. So that is where, it's not just one unit actually, one machine learning ops kind of work. So all your DevSecOps, all your security, all your DevOps, all have to come together for a successful path. So it's creating, and also, you can verify it. You can go back here. Let's go back to this this service, SageMaker service. you have completed training, right? Training job is over. So now you come to inference. So you come to endpoints. So it is in creating stage. It will take some time to provision. And once this is up, then we can fire our prediction queries to this endpoint and get the result actually. So this is where, and no, this is one area which can make you very poor if you forget to keep, turn it off after you are experimenting. So it will consume a lot of money actually, because endpoint, it also creates an instance behind the scenes. Okay, so whenever you are playing around with AWS or any other cloud, keep a billing alert. And the second line of defense, you always verify what instances are created behind the scenes. Normally, this will be taken care if you are not experimenting and your company is have enough network engineers and cloud engineers, they will take care of it. Don't worry. But if you are playing around, be mindful of these things. So let it run. It is going to run for some time and it will create the endpoint. Then we can use this service basically. So we are almost reaching closing stage. So I can briefly go back to the PowerPoint, quickly run through few things. Then I think hopefully we should close in 10 to 15 minutes max. Yeah, so these are something like AWS specific things, what are all the AWS specific services which are available. Okay, I will circulate this presentation deck later to Vijay. So, yeah, so almost, all these cloud things, right? They have hundreds of services basically, right? And you cannot explore in this lifetime basically, right? So what's going to happen every day, this cloud vendors wake up, they create one new service. Okay, so it's like, it's not possible to master all these things, but good to know. Good to know. Always you can refer back to the documentation, and AWS provides a very good developer guide, which is running into 2,000-page document. Okay, so even you cannot read it, I cannot read it, no human can read it, but what we can do, you can refer it basically. So based on your business needs, come back, refer it, use it. Okay, so all these are like, I have just tabulated. I'll give the book reference behind in the last page. So there are very good books on this subject, so you can refer those. So yeah, the important thing is, I'll have to, yeah, this is what I wanted to cover actually. So AWS gives us 3 options to bring your model and deploy. Okay, one is built-in algorithms. This is something like you don't have to worry about which model to import. You can use AWS built-in. They have something like their own version of XGBoost, their own version of logistic regression, which is promised to run much faster and more efficient, okay, in their network. Okay, so that is option number 1. Normally, people who want tech agnostic thing will not prefer it. Okay, so third option I'll go to. Third option is the other extreme. Everything you build, custom built. Okay, you create your container, push that image to AWS, and then deploy it. Okay, so that is option. That is the other extreme of it. So the third, kind of balancing act is bring your own code. So AWS gives you framework. Okay, so it gives you scikit-learn framework, TensorFlow framework, a PyTorch framework. Multiple different frameworks it gives you. You use that framework, and you can write your custom code. And the AWS will create the containers behind the scenes. So this is kind of, I find, somewhat a balancing act. All these things has pros and cons, but you evaluate based on your need. Okay, that's my advice. Okay, so let's go back and see. So this is one important thing I wanted to cover. So let me quickly check back this one. Okay, now you see this endpoint is created and also it is in service. Okay, so this is very important. So if this is in service, now let us go here, verify it, whether it is also created here. So if you might see here, So it is in service. So if this endpoint is in service, now you can use a query, get back the result. I'm going to quickly do it. But if you see this service name, it is staging. No, it is not yet in production. So it is one level below production. We are almost there. Okay, so, but not yet in production, because one final level data scientist has one more last say, telling that, at least this time I can back off. So after it goes to production, still you can back off, but during using that will become a bit cumbersome actually. So we'll give them one more opportunity to decline this. So what we are going to do, I'll go to the SageMaker Studio. So Studio, I have already opened it. So let me go here. So this is the use of this particular thing, right? You can play around with the terminal, everything here itself, okay? So if your S3 is working, I normally do this test like we check the Google, right, for internet connectivity. Similarly, I check if your AWS is set, right? So then what you can do, I'm going to issue a command. So we can invoke this endpoint basically. Yeah. Okay. So our endpoint name is this one, staging. Let's keep it like output 4. So what it's like, I am invoking the command line prompt. You can always write a Lambda function, fashion it, with the API gateway, all those things, right? So as long as your CLI works, everything works. Okay. So let's go here. Let's see our endpoint name actually. Okay. Yeah, endpoint name is demo staging, right? So you go to terminal. Pasting. Here is this demo 1, right? Name is all correct.
Shift right. No, say shift right.
What is it? Can somebody try their luck actually? Anyone want to paste it? Shakti, can you check this?
So shift right.
Paste this command actually. Yeah, paste this. Yeah. Please, what is the command? Okay, let me type it.
I think you have it right.
Okay, so idea is like now it is actually predicted. So if you can catch this. Good. So now it is predicting the shellfish age to be some 8.78 or something, right? So the point is like the prediction model itself is not important, but you are able to expose an endpoint and that endpoint is working fine. So that is the important thing. Now, like I said, the promised last step, okay? So let me go through the services again. And we talked about code pipeline, right? So this code pipeline can replace with Jenkins pipeline, all those things. Okay, so now if you see this one, so it finally waits for one more approval. Okay, approve to deploy. Okay, so this is where one final chance people can reject it. After that also you can roll it back, but this is where I say approved because I play the role of both. So I approve it. Normally this doesn't happen so easily. So once this is approved, it will create a production endpoint. Okay. Now if you go to your endpoints, so normally it should start to kick off one more endpoint actually. So people can happily experiment with staging as long as this is typically we call in software engineering UAT. Okay, you do a user acceptance testing using this one. No, you don't expose everything to production. But after we assume all things are fine, you click the approve button. Now, actually, one more endpoint is going to come. So let's go to SageMaker. From code pipeline, this is approved. So we should go to SageMaker and see. Yeah, one more service is creating now. So this is going to be a production endpoint. Okay. So once production endpoint is exposed, then you can actually use that to build your application. And typically now you are in a position to do a prediction, right? So now we started with machine learning, building, made it operational. It is usable now, also trackable and scalable, all those things, right? All those good things. So that's about it. Okay, so let it run. And meanwhile, any queries or any questions, if you have around, I'll try to. If I know, I'll answer. Otherwise, I will pass. Yeah, tell me.
Sorry, one video which was GPU clusters. Like I know GPU clusters will be available for SageMaker, but is it something on demand available? For example, I'm building an application for video inference. Customers may not. I mean, we don't need consistent GPU computation. Only on demand. Is it possible?
So you are asking about scaling, right?
I'm not about scaling actually. Let's say I have 100 GPU clusters for video inference, right? Yeah. But I'm not going to consistently use those 100 GPU clusters, which is going to be a huge cost for us, right? But is it something like only when customers are using my application to upload videos? Like let's say it is going to take only 5 minutes of GPU cluster time, right? Yeah. Only that 5 minutes can then GPU clusters available. Right?
I think what typically you can build a solution around it. You can create a machine group actually. So AWS by default gives this type of scaling to inference pipeline, not for the training pipeline. Okay, for training, what you can do is you can before you are training, you can create some different varieties of environments. So, for example, that you can spin up an application logic should handle it. Okay, what type of, because this instance on demand while creating your job beforehand, you can provide it. So it can come like a parameter. So if there is a user group, you want to operate on GPU compute, some user want to operate on memory optimization instances. Some users want to operate on CPU optimization instances. All these things can be done. Okay, but you have to build some logic around it. Okay, and regarding inference pipelines, it is tightly coupled with auto scaling. So what you can do is like you can set some threshold. Okay, beyond the CPU, I'm going to automatically scale it to one more parameter, right? And you can also do a cool down. Like if it is not used, you can scale it down also.
So in some cases, if we want, auto scaling might not be the best solution because we want a quicker scaling of solution.
Right.
Will it be able to? Can we do it? Can we write our own
See,
scaling?
what happens is like normally auto scaling is a design issue. So you have to auto scaling is like just you are at a war scenario and it is happening, right? You have to include this design beforehand. That's why we have this staging. Okay. So staging you can predict your workload. It gives you metrics regarding CPU, memory, everything, and you can see what is the best best possible solution or what is the best possible instance to handle your workload, and basically define that. And auto scaling as a second level of frequency can keep.
How do you manage all these containers? Like, let's say, have 10 modules on SageMaker.
Right.
Each of them have their own endpoints.
Right.
Is there a consolidated dashboard kind of facility where I can see the containers being monitored?
See, actually, each of these things they expose APIs. So that is something you can do an API query and build an app actually. So everything, they have all this information, but it's all available in raw form. So, but this is trackable. Like I said, if I go to that training job and show what images used behind this. So that level of capturing is there. But if you really want to, as a dashboard, you have to build it custom. So that is the thing. Like you can query a training job. End of it, you persist that data into a DynamoDB or some database and issue a dashboard on top of it. So that is a custom built logic here. As per my knowledge. Okay, but tomorrow, fine day, AWS will wake up and do that also. We don't know, right? Like whatever information, like I put a disclaimer, this is for my knowledge as of my last working yesterday, right? So tomorrow, because these things, the changes happen so fast, right? Next hour, by the time, I don't know whether this job will work also. By the time they might have made some change, right? So these things happen pretty fast, very changing in nature. So whatever information we tell you is based on our own interpretation and our own experience. So that big disclaimer I'm putting. Okay, and please test yourself, benchmark it, read documentation. That's the general advice.
You have mentioned in the feature group that we're doing image-based models.
Features.
Yeah. While explaining the feature group feature in the same.
Right.
You mentioned that the image, while doing image-based models.
Yes. Any feature engineering intensive model.
Yeah, usually with images, right, it's automatic feature extraction for deep learning models, especially for computer vision, like segmentation, keyword detection.
Correct.
How that will be helpful for resisting the model?
The extraction part, right? The feature extraction and those things, right? It is time consuming. Like I said, these are feature engineering and all. Feature store is an optional step. So it is not a mandatory step for your engineer. But let's say your feature extraction job runs for 5 hours. Okay. Then your training kicks off after that. Now, let's say your feature engineering is fine. Your training is failing. Now you have to start from the scratch actually, in a typical conventional scenario. But if you have feature store, you know that the features are extracted. So you can start from there. So which will save you some time. So that's the whole idea of it. Okay. I think once this is done, we are almost done. But I don't want you guys to wait till this happening, because all the things are already demo. I don't want to interrupt lunch or networking. Right? So I don't want to be the man standing in between. So let me take it a close here. Okay, and thank you all for joining.
We have keeps the guidance moving. And you can connect with everyone based on your availability. And if anybody interested, please let me know your feedback also, like how we can make it up. This is the first time we are conducting, so.
Yeah, and good news to know this also, the service is created. So that's it.
Yeah, so we have cafeteria here.
We take group photo.
We will take one minute photo. Just. I think here we can have it, right? Here we can have it.
Which course you made that? Course. Oh, the initial one actually. I wasn't. Yeah. Now we released it. Yeah, now I am not closely following this. 2018, I was I think that time was one of the initial companies.
We have to announce on the bridge as well that it is completed.
Sorry?
Yeah,
We have to announce it on the bridge that it is.
They are already there.
Yeah,
that will take a baseline.
Which laptop?
Then there is a secret to automatically bring out everything.
So this meetup is completed. So I'll just stop the screen share. Thank you all for joining.
Or we have to approve the retrain. It's your design. So you can always create a human in the loop or you can.
Yeah, I'll just show that here. So
Yeah.
You want to put your TensorFlow background?
yeah, that's what I'm trying.
No, you have to try it here.
Not that one.
Yeah, this is the one which is connected.
I'm doing here. So that's all. It's connected, I think.
Oh, yeah. I think AWS has its own scaling for the custom. Yeah. AWS specific.
So we have to override.
I don't know that. But it's possible. All these things are possible. Personally, I haven't experimented. Good.
I think this is fine, right? We can stand here and take it.
Yes.
Okay.
Yes,
Yeah,
yes, we
we'll
can
stand here in 2 lines.
You just come here.
People will cover you.
Thank you. Yeah.
Thank you. Thank you. Join us as an
I don't know, it's a nice system, but anyway. They have a MXNet. MXNet is part. Not a very popular. Yeah. Oh, books. Yeah. Hey, one last slide, guys. Take a picture. Have you written any books? I've not written. That's marketing. See, I refer many books. These four things, throw some initially good. Refer 10 but at least these four are kind of starters. Starters also will can actually refer these things to.
I'll share this PPT with everyone.
Yeah.
We'll upload it data and we'll share it. Welcome. Please come to capital. Oh, okay.
Trying to myself.
Last set over there.
ಅದನ್ನ ಹಾಕ್ಬೇಕು. ನಾ ಮತ್ತೆ ಮಾಡೋದು.
Obviously, app development. I mean, enough TensorFlow for JavaScript. Other person, overall, application development.
Go ahead. David. Go for.
Thank you.